Okay, here's the problems you guys requested. Mike can run the mile, it means 1 mile in 6 minutes. Dan can run 1 mile in 9 minutes. If Mike gives Dan a head start of 1 minute, how far from the start will Mike pass Dan, and how long does it take? Now with this head start crap, what you want, you're going to make 2 tables. And they're 2 rows by 4 columns. It's called what I call the dirt table. Okay, so we got Mike and Dan, Mike and Dan. And what I do is put speed, distance, time, and speed, distance, time. Okay, so if we don't, speed is distance, and you need to know these formulas. Speed is distance divided by time. Distance is speed multiplied by time, and time is distance divided by speed. And then it's likewise up here. Distance divided by time, S times time, and distance divided by speed. Okay, so without the head start, it talks about 1 mile. Now 1 mile is distance. The speeds we don't know. That'd be the per. Okay, so 1 mile, 1 mile, and then Mike can run it in 6, and Dan can run it in 9. Well, then I can write some for my speed because I know it's distance divided by time, so the distance is 1 and the time is 6. Leave that as 1/6. Okay, because that 1 divided by 6 comes out as a decimal that never ends, and that's 1/9. Okay, I've accomplished what I wanted to here because my speeds don't, the speed of a human being doesn't change, okay? You can't really speed up a human. He's either fast or he's slow, so those stay constant. Now, when they get into this race, you don't know the distances they travel. That's part of the deal. But you know he gives him, for the time, he gets a minute head start, okay? So the minute head start means this guy, Dan, who runs slower, okay, because 1/9 is slower than 1/6, he runs for a minute, gets to run for a minute longer. So you don't know it, but you know he runs for a minute longer, and then this guy is just X. Well, now I can write at least something for the distance, okay? S times T. 1/6 times X would be 1/6X. And then I would distribute the 9 to each one of these. 1/9 times X is 1/9 X. It's like the rainbows. 1/9 times 1 is 1/9. And the distances they travel, remember, you want to find when they catch up to the other. So that means when are the distances equal, okay? So you can set these equal. 1/6X equals 1/9 X plus 1/9. And we subtract the 1/9 X from each side. And then you use your calculator. 1 ABC 6 minus 1 ABC 9. And I got 1/18. So 1/18 X equals 1/9. Okay, now, if that was a whole number you'd divide, well, it's no different with a fraction. You can divide both sides by 1/18, okay? Now, you could flip that then to 18 over 1, 1/9 times 18 over 1, or you can just divide 1/9 by 1/18. It accomplishes the same thing. So X is 2. Now that I know that X is 2, I know this guy ran 2 minutes, or seconds, I guess. Whatever it is. This guy ran 2. And then the distances, I know that's 2, and I know that's 2. So I can figure out what they want me to find. So first off, the second part of that problem, how long it takes, okay? The time is 2 minutes. We'd go with Mike, because I think they want to know when Mike starts. So 2 minutes is how long it takes. And to find where they're at, well, that's related to distance. So I can take 1/6, and they should be equal. 1 ABC 6 times 2. That's 1/3. And then 1 ABC 9 times 2 plus 1 ABC 9, and that's 1/3. So where they end up at is 1/3 of the mile. So those are both answers that you'll need. Okay, now the other one, the football problem. A tight end can run 100 yards in 12 seconds, a defensive back in 10 seconds. That means he can run 100 yards. A tight end catches a pass at his own 20 with the defensive back at the 15-yard line. If no other players are nearby, at what yard line will he catch him? Okay. All right, so again, we make a table of just the general information, and the table that is the actual race with this head start. So we got tight end, defensive back, tight end, defensive back. So there's the speed, the distance, the time, the speed, the distance, the time, and speed again is distance divided by time if I need it. It's distance is speed times time if I need it. Time is distance divided by speed if I need it. So again, distance over time, speed times time, and distance divided by speed. Okay, so we the speeds we don't know, okay, at the moment. The distance they're going to run is 100. The general information is they can each go 100 yards, and this guy in 10 seconds, he's a defensive back, this guy in 12 seconds. So speed, I could do 100 divided by 12 and 100 divided by 10. Now 100 divided by 10 is 10. Okay, we need to put that. But 100 divided by 12 isn't quite so easy. Okay, got 8.3 repeating. Again, you can't really round on these, so you go 100 ABC 12, and it'll write it in the simplest fraction form possible, which is 8 1/3. Okay, remember what we said for the first problem. The speeds, everybody's human, so the speeds aren't going to change. Now, the distances is just about the yards. Well, think of it. You got 20. He's at the 20-yard line. He's at the 15-yard line. So when this is happening, who's going to have to run 5 further yards for them to catch? Not the tight end. He's already ahead. The defensive back has to run 5 more yards. You might think it's a tight end just by reading it because you're like, oh, he's 5 yards ahead of him. Yeah, that means this guy has to run 5 more yards during the time span. Okay, and this guy's X because he starts behind, so he's got to run 5 more. Then the time, we know we can write that as the distance, X, divided by the speed, 8 1/3. X plus 5 over 10. And these are equal because they're going to be running for the same amount of time. Okay, a football play starts and stops. Everybody's moving and running at the same time. So, X, we have a proportion. X over 8 1/3 is equal to X plus 5 over 10. And then we use our cross products. 10 times X is 10X. 8 1/3 times X is 8 1/3 X. Then 8 1/3 times 5 is 41 2/3. Okay, so let's subtract 8 1/3 X from each side. And that's 1 2/3 X. You should be able to do that in your head. It's a little less than 2 by 1/3. Equals 41 2/3. Then I divide, even though it's not an integer, I divide by the mixed number. And if you have a calculator, you can just calculate it. 41 ABC2 ABC3 divided by 1 ABC2 ABC3. And I get 25, okay? So these X's that were unknown now, he travels a distance of 25 yards. He's going to travel a distance of 30 yards. Okay, now you got to do some thinking here. Okay, now when he caught the pass, the tight end was at the 20. So the tight end has run 25 yards. 20 plus 25 is 45. And the defensive back started chasing him when he was at the 15. He's ran 30 yards. 30 plus 15 is 45. So they catch up at the 45-yard line. Okay, remember one more thing. With those 2 percentage mixture problems, it's like we did last year, but you're not going to have the third column, okay? how many percent, and then I just leave that down here. So let's say we got 3% and 5%. You know, I'll just go. Usually it's a bigger one first, 5% and 3%. Okay, now those as percent, 0.05, 0.03. So if you dump, I don't know, let's say 15 milliliters, so you'd have 15 at the starting percent, and then you'd have the leftover. Evaporate means it goes away. Some goes away. So I don't know how much, so I call it 15 minus X. Okay, and that's going to be 15 times 0.05, 0.75, and then over here, 15 times 0.03 is 0.45. Actually, never mind. Sorry, that was all screwed up. I don't have a problem in front of me to read. It's always the smaller one first, okay? 3%, 5%. You put the smaller than the bigger, okay? Then how many? So 0.03, 0.05. Okay, so I'm going to dump 15 at the beginning, and then the remaining amount, how much is remaining? Well, I don't know how much I put in there, so it'd be 15 minus X. Okay, and then 15 times 0.03 is 0.45. And then I distribute, okay? 15 times 0.05 is 0.75. Minus, and then you're going to have 0.05x. And then you set these equal to each other, okay? So 0.45 equals 0.75 minus 0.05x. Okay, minus 0.75 minus 0.75. That's going to be negative 0.3. And we have negative 0.05x. Then I divide. And x is equal to 6, okay? So you start off with 15, so we have 6 and 9, okay? 15 minus 6. Now, should you have a problem with 3%, okay, you're going to make 3 of them. And what you do is you put your lowest, then your highest, I'm just making up numbers, then the middle, okay? And usually what they do is they'll tell you how many milliliters or whatever is you want the N to be, okay? So you'd have, I don't know, let's say, or they'll tell you how many milliliters you start with, okay? So it'd be like 15. Or actually, I'll get a problem here and read it. Problem I'm a little more familiar with out of our textbook. I need to see a problem kind of before I tell you. So with 2%, you go with the first way I showed you. Where's systems of equations at? Here we go, okay. In a chemistry lab, you have 2 vinegars. One's 5% acetic acid, one is 6.5% acetic acid. You want to make 200 milliliters of a vinegar with a 6% acetic acid. How many milliliters? So you want to make, you got 3%, so you're going to need 3 columns. You put the lowest, the highest, the 2 you're mixing, and then kind of the middle. Okay, and then the percent, 0.05, 0.065, 0.06. Now you started with 200 milliliters, okay? And then we'll have this be X, this be Y. You could also have this be 200 minus X too. 0.05x, 0.065y, and then I actually need to take 200 times 0.06. That's 12. And then I write a system of equations. So x plus y equals 200, 0.05x plus 0.065y equals 12. So multiply by 0.05 on top, and then bottom we're not really multiplying because it's 1. So 0.05x plus 0.05y, 200 times 0.05 is 10. And the bottom remains the same, 0.05x plus 0.065y equals 12. Make these bad boys all negative, okay? Okay, I'm going to add those two. 0.05 plus negative 0.065, I get negative 0.015y. And then negative 2, then I just divide negative 2 by negative 0.015. Okay, 133.3, which is 133 and a third. Okay, that's your y. And then to find this, you just minus 200 minus this. It says both of them. Another way you can set that up, you can do it a different way. This way is a little bit quicker, but it's not really the way we did it last year. 5%, 6.5%, and 6%. And then how many, my percents. And usually on percents, I leave that bottom row blank. 0.05, 0.065, and then 0.06. And again, they want 600 of the 6% of the 200. You can call this x, and then this one could be 200 minus x. Okay, it's another way you can do it. So 0.05x minus, and that'd be 0x has to be multiplied by that too, 0.065x, and then that is going to be 12. And then I have this equation here, okay? So I can add these two, this to negative, because negative 0.015x plus 13 equals 12. Then I subtract 13. I get negative 1. And then I have to divide my negative 1 by negative 0.015. Okay, I got 66. Okay, I'm going to actually make that into a 66.6. That's 66 and 2/3. That's your x. And then here you just take 200 minus 66 and 2/3. Which is 133 and a third, which is the same answer I essentially got if I did it the other way. Okay, pick a way with the 3% that best works for you would be my advice.